Today we are going to study about the topic DC machines, and in the subject PCEET 303. Today we are going to deal about the constructional details of DC machines. Okay, so you can see this diagram here. As we already know, DC machine is nothing but DC machines are the machines which can operate either as DC generator or as a motor. Here, in this DC machines are mainly classified as DC generator and DC motor. So you can see the constructional diagram of a DC machine. In this one, the major parts are displayed in this diagram. You can see the field winding is the main part, one of the main part of the DC machine. The next one will be our armature conductors. So armature and the field are the two main parts of a DC machine. And in this diagram, you can see this stator part is the one which is stationary and rotor part is the one which is rotating in nature. So here you can see the field windings are attached to the yoke which is stationary in nature, and the armature conductors are placed attached to the near to the shaft so that it will be in the rotating part. Other parts you can see here, the commutator segments, brushes, etc. So this is the constructional diagram of a DC machine. If it is asked for construction of DC motor and DC generator, all the questions will be same, all the answers will be same. So you can see this one here, the field windings are, you can see this one, the field windings are attached to the external yoke which will be providing the mechanical support to the machine. So this field is mainly, this is a 4-pole machine, you can see north, south, etc. So in this one, especially you can see the field windings are attached to this field, right? So this shading will be representing the field windings, and the inner part you can see the shaft part, isn't it? You can see the arrows. In this one you can see the shaft part. In this shaft part, the shaft is the one which is the rotating in nature. So our armature conductors, this is our commutator part, and this is our armature conductors. So there will be an air gap between the stationary field and the rotating armature. So this part is called as the air gap area. So air gap is nothing but that is the distance between the separation between the stator and the rotor. Normally this part we will be keeping this part as 0.5 to 0.6 mm to get the uniform flux distribution. So you can see the main parts like field windings, then armature conductors, commutator, interpoles, yoke, pole shoe, shaft, etc. So in this one of the main part is our commutator. You can see these commutator parts. So commutator is nothing but which will be converting the AC waveform to AC supply into DC form. Or in simple you can say that it will be converting the bidirectional supply to a unidirectional flow. Okay, so that is all about the commutator segments. Then next one you can see is our so one by one we can go. So here this is the diagram what you have to draw while asking the construction of DC machine. So as we already told, the main parts of DC machine are our magnetic field or field system and the conductors, armature conductors. So the magnetic fields are produced by electromagnets. Mainly copper conductor is used in the case of magnetic field, and we have so many conductor winding which is known as the armature conductor, which are placed on the armature slots. So we already know in any machines excitation supply will be always will be DC supply, and field windings are usually for conducting electric current as it is, since it is electromagnets. Then you can see the pole shoe structure for the field you will be, this is the pole shoe structure of the field magnet. You can see this one. So pole shoe is nothing but this is called pole shoe. Pole shoe is the main function of pole shoe is to hold the field winding in that area, and it will be concentrating the flux to the center, and also uniform flux distribution will be ensured by these pole shoes. So the outer covering of the overall machine is, we will be calling it as yoke. That will be our mechanical support will be provided by this yoke. Then our armature side, you can see this armature. These are the armature conductors which are placed inside these armature slots. These are called armature slot, and we will be placing these armature conductors. Here 4 conductors in a single slot. You can see, right? 4 conductors in a single slot. So these are also provided in this armature. Conductors are placed inside these armature slots. So armature is nothing but it is the assembly of conductors. The arrangement of this armature winding is in a we can do in different manners, mainly cylindrical in structure, and we can provide this armature conductors mainly in 2 types of winding we can provide for these armature conductors. Mainly we will be providing lap winding and wave winding. Like these conductors can be wind in lap mode or in wave mode. So if in lap winding, if we have 100 conductors and 4 poles, then the division of conductors in one parallel path will be done by 100 by 4. That is 25 conductors will be placed in each path. If in the case of wave winding, if there is 100 conductors and we have to divide them in these poles, then always irrespective of the poles, the winding should be always divided into 2. So wave winding, the value will be 2. In lap winding, the number of parallel path will be same as the number of poles. A will be representing the number of parallel path, and Z will be representing the number of conductors, and P will be representing the number of poles. So in the case of lap winding, number of parallel path is equal to number of poles, and in the case of wave winding, number of parallel path is always 2. Then next part is our commutator, as we already said. Here in DC machines, normally split strings or slip rings we can provide for the in the case of commutator, split ring and slip rings. So it is only used in DC machines. It always we generate AC, and to convert it into DC, we will be providing commutator segments. And brushes you can see here. These are our brush part. This is our brush. You can see these brushes. So these brushes are normally providing for what purpose? Brushes are normally providing attached to the commutator segments, commutator segments, the brushes are attached. So carbon brushes are normally used in the commutator segments. They will be helped to transform the voltage developed in the machine into the external circuit. Okay, that is all about the construction of DC machines. So with this, we will be concluding the first session of our topic.